Voyager 1 probe, the most distant human-made object in the universe.
After more than 4 decades in space, Voyager 1 continues to send crucial data that can be quickly interpreted by yet another technology, quantum AI. Yes, a breakthrough in space exploration just happened. It has detected something alarming in an image sent by the old spacecraft. Could this be the discovery of a lifetime or just an unexpected glitch? Stay tuned as we dive into this cosmic mystery. A new frontier in space exploration. When you think about Voyager 1, it's impossible not to get a little awestruck. Launched by NASA back in 1977, this spacecraft is like a digital time capsule, traveling further than any human-made object ever. It's currently over 14 billion miles away from Earth, zipping through the cold, dark expanse of interstellar space.
We may have to revise our theory of the creation of the universe.
But even after all these years, it's still sending back data that's been invaluable for scientists trying to understand the outer limits of our solar system and the surrounding galaxy. And here's the exciting part. What if we could take that incredible treasure trove of information and give it a massive boost by using quantum AI? It's like putting Voyager 1 on a supercharged turbo boost of intelligence, helping us unlock even more mysteries faster and more accurately than ever before. The idea of combining quantum AI with the spacecraft's data brings us into a new era of exploration. Instead of having to manually sift through all the information, often taking years of work, this new technology could help us make sense of the data at lightning speed. With quantum AI, scientists could have more time to focus on breakthroughs and big discoveries rather than the painstaking process of data analysis. Think of it like having a superpowered assistant that can spot hidden patterns, detect anomalies, and even predict future events based on Voyager's findings. It's not just a dream for the future, it's a tangible way we could unlock a whole new world of possibilities in space exploration. What is quantum AI, and why does it matter? Now, let's take a step back and break down what exactly quantum AI is, because it's a concept that sounds futuristic, because, well, it is. Quantum AI is a fusion of 2 powerful fields, quantum computing and artificial intelligence. Quantum computing, which builds on the principles of quantum mechanics, gives us a brand new way of processing information. Instead of relying on bits, which are the building blocks of classical computers, quantum computers use qubits. These qubits can exist in multiple states at once, thanks to the phenomena of superposition and entanglement, allowing them to process massive amounts of data far faster than classical systems ever could. This might sound a little confusing, but the point is this.
Quantum computers aren't supercomputers.
Quantum computing is capable of performing calculations and simulations that would take even the most powerful supercomputers centuries to complete. Combine that with artificial intelligence, which can learn from data and make predictions or decisions on its own, and you get a tool that can process and analyze data at an unprecedented scale. In terms of space exploration, this means that quantum AI could sift through vast datasets, like the ones coming from Voyager 1, and spot subtle patterns or trends that a human might miss, making it a game changer for uncovering the mysteries of the universe. Since Voyager 1's launch, it's been steadily collecting and sending back data about our solar system and beyond. But this data is incredibly complex. The spacecraft has taken pictures of distant planets, moons, and the outer reaches of our solar system, while also measuring things like cosmic rays, magnetic fields, and radiation levels. All of this information paints a rich picture of the universe's outermost layers. However, the data is scattered, dense, and at times really tough to make sense of. This is because space is filled with so many variables that even the best minds in science can get overwhelmed. So much data means it's easy to overlook small, subtle details that could lead to groundbreaking discoveries. That's where quantum AI comes into play. Traditional computers have their limits when it comes to processing and analyzing massive datasets like those coming from Voyager 1. It's not just about crunching numbers, it's about making sense of patterns across many different kinds of data. AI has already made a huge difference in fields like medical imaging and even predicting weather patterns. But space data is different. It's often messy, uncertain, and constantly evolving. Quantum AI could bring a level of precision and speed that human scientists just don't have the luxury of using. With quantum AI's help, Voyager 1's data could be analyzed and interpreted much more effectively, leading to discoveries that might have taken decades to uncover otherwise. How quantum AI could supercharge Voyager 1's discoveries. Think about it. Voyager 1 has been sending back data for over 4 decades, but there are still mysteries in those datasets that haven't been fully solved. Imagine if we could take all of that raw data, from images to radiation readings, and let a quantum-powered AI go to work. This AI could comb through the data at lightning speed, noticing tiny fluctuations or patterns that humans might miss. For example, Voyager 1 has been measuring cosmic radiation and magnetic fields as it moves further and further from the Sun, passing through the boundaries of interstellar space. These measurements are key to understanding how the solar wind interacts with the surrounding space environment. A quantum AI could pick up subtle changes in these measurements that point to entirely new phenomena, like previously unknown interactions between solar and interstellar particles. On top of that, Voyager 1 has captured some of the most famous space images in history, like the pale blue dot photo of Earth taken from billions of miles away. But with the help of quantum AI, we could begin to dig into these images even more deeply.
Quantum mechanics, the result of the experiment, cannot be explained by the events that we see.
We might be able to identify hidden features in distant planets and moons that weren't visible before, or maybe uncover strange cosmic events in the background that we never noticed. The power of quantum AI to process image data and detect patterns in ways human eyes can't might reveal hidden details that completely change our understanding of the universe's farthest reaches. If there's something big or groundbreaking hiding in the data, quantum AI could be the key to unlocking it. How's Voyager 1 for the recent months and years, by the way? A short pause. Considering its old age, Voyager 1 has its own technical challenges and limitations. One of those is its consistent ability to just be perfectly available out there. It slept for 5 long Earth months, and after 5 months, it's back to work for the experts. An almost impossible thing to do. In the realm of space exploration, NASA's Voyager 1 stands as a beacon of human ingenuity, perseverance, and curiosity. Launched in 1977, the spacecraft has journeyed farther than any human-made object, currently residing in interstellar space.
All those trajectories interfere them to make an accurate prediction of what states to see in the future.
However, even this extraordinary mission has faced challenges, one of the most significant being the temporary loss of connection in late 2023. This hiatus underscored the complexities of managing a spacecraft billions of miles away while reaffirming the dedication of the teams supporting it. In November 2023, Voyager 1 experienced a technical anomaly that disrupted its ability to send coherent data back to Earth. The spacecraft, approximately 15 billion miles away, relies on systems designed over 4 decades ago, making troubleshooting particularly challenging. Signals from Voyager 1 take over 22 hours to reach Earth, complicating real-time communication. The disruption was traced to a defective component within the spacecraft's communication systems, which led to the transmission of indecipherable data. This setback temporarily halted its ability to send updates about its condition and scientific observations. Restoring Voyager 1's connection required ingenuity and persistence from NASA engineers. Despite the spacecraft's age and the immense distance, the team worked tirelessly to identify the problem and devise a solution. By March 2024, they successfully reprogrammed Voyager 1's systems to bypass the faulty chip, restoring its ability to communicate with Earth. This achievement highlighted not only the robustness of the spacecraft's design, but also the expertise of the mission team in adapting to unforeseen challenges. Is the hiatus important? The temporary loss of communication with Voyager 1 served as a reminder of the difficulties inherent in long-term space exploration. Operating a spacecraft with limited power and outdated technology in the harsh environment of interstellar space is no small feat. Yet, the successful restoration of contact demonstrated the resilience of the mission and the commitment of the scientific community to extend its lifespan. With communication restored, Voyager 1 continues its mission of exploring the interstellar medium, providing invaluable data about the environment beyond our solar system. While the spacecraft's power supply is gradually diminishing, the mission team remains optimistic about its ability to operate into the late 20s. The lessons learned from this hiatus will undoubtedly inform future interstellar missions, ensuring that the legacy of Voyager 1 endures. In overcoming this challenge, Voyager 1 has once again proven its status as a symbol of human ingenuity, a testament to our desire to explore the unknown, and a reminder of the enduring spirit of discovery that drives space exploration. Let's make a recap of all of Voyager 1 discoveries and contributions in space exploration. A recent discovery. We can't be familiar with everything, so let's make a brief and simple introduction of terms. The word interstellar means between the stars. It refers to the vast space that exists outside our solar system, but still within our galaxy, the Milky Way. This space is mostly empty, but it contains very thinly spread gas, dust, and particles like plasma. It's the region where the sun's influence fades, and the environment is shaped by the stars and the galaxy itself. For example, when scientists say that Voyager 1 has entered interstellar space, they mean it has traveled beyond the protective bubble created by the sun, called the heliosphere, and is now in the space between the stars. Since its historic launch in 1977, NASA's Voyager 1 spacecraft has served as a pioneer in space exploration, offering unprecedented insights into the cosmos. Now, traversing interstellar space, Voyager 1 continues to provide groundbreaking data, particularly about plasma density, a fundamental property of the interstellar medium. These discoveries have significant implications for our understanding of the universe and our place within it. Plasma, the fourth state of matter, consists of charged particles such as electrons and ions. In the context of interstellar space, plasma density refers to the number of these particles per unit volume. Measuring this density is critical to understanding the physical properties of the interstellar medium, including its turbulence, temperature, and interaction with the heliosphere, the protective bubble formed by the solar wind around our solar system. Voyager 1's data on plasma density help scientists map the transition from the heliosphere to interstellar space, shedding light on how the sun's influence diminishes and the true nature of the interstellar environment. One of the key instruments enabling these discoveries is Voyager 1's plasma wave system. By detecting oscillations in the surrounding plasma, the instrument measures the density and characteristics of the interstellar medium. Notably, after crossing the heliopause in 2012, the boundary where the solar wind gives way to interstellar space, Voyager 1 recorded an increase in plasma density, confirming its entry into a new cosmic frontier. Recent measurements have revealed density fluctuations in the interstellar medium, offering clues about the dynamic processes shaping this seemingly empty expanse. These findings indicate that the interstellar medium is more structured and turbulent than previously believed. The insights provided by Voyager 1's plasma density measurements have far-reaching implications. They improve our understanding of cosmic phenomena such as stellar winds, magnetic fields, and the life cycle of stars. By characterizing the interstellar medium, scientists can refine models of galactic evolution and better predict how interstellar conditions might affect future space missions. Moreover, studying plasma density in interstellar space deepens our understanding of the heliosphere's role as a protective barrier. As the sun's influence wanes, Voyager 1's data reveal how cosmic rays and other high-energy particles interact with the heliosphere, informing our knowledge of radiation environments in space. Voyager 1's journey through interstellar space is not without challenges. Operating at a distance of over 15 billion miles from Earth, the spacecraft relies on aging technology and a diminishing power supply. Despite these limitations, its continued transmission of valuable data underscores the resilience of the mission and the ingenuity of the teams supporting it. Looking ahead, Voyager 1's plasma measurements will contribute to a more comprehensive understanding of the universe's vast expanse. As the spacecraft ventures further into interstellar space, it will likely encounter new phenomena, pushing the boundaries of human knowledge. By unraveling the mysteries of the interstellar medium, the spacecraft not only enhances our scientific understanding, but also inspires a deeper appreciation for the universe's complexity and beauty. In its continued journey, Voyager 1 remains a testament to human curiosity and the relentless pursuit of knowledge. Discoveries of the first Voyager. Launched on September 5, 1977, Voyager 1 has become one of humanity's most remarkable achievements in space exploration. Its primary mission was to study the outer planets of our solar system, but it has since ventured into interstellar space, making groundbreaking discoveries that continue to reshape our understanding of the cosmos. Thanks to this spacecraft, we knew about the enormous planet Jupiter. Voyager 1's first significant milestone was its encounter with Jupiter in March 1979. The spacecraft captured stunning images of the planet and its moons, revealing unprecedented details about its atmosphere, magnetosphere, and moons. Among its most notable findings were the discovery of active volcanism on Io, one of Jupiter's moons, marking the first time volcanic activity was observed beyond Earth. It also revealed Europa's smooth, icy surface, sparking speculation about subsurface oceans that might harbor life. Additionally, Voyager 1 provided detailed images of Jupiter's Great Red Spot, a massive storm system, and mapped the planet's faint ring system. In November 1980, Voyager 1 reached Saturn, delivering new insights into the planet and its complex ring system. The spacecraft captured detailed images of Saturn's rings, revealing intricate structures such as radial spokes and wave-like patterns caused by gravitational interactions with the planet's moons. It also provided close-up views of Saturn's largest moon, Titan, which revealed a thick atmosphere composed primarily of nitrogen and methane. This discovery suggested the possibility of organic chemistry on Titan, laying the groundwork for future missions like Cassini-Huygens. After its planetary encounters, Voyager 1 embarked on its interstellar mission, continuing to send data from beyond the solar system. In August 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind gives way to the interstellar medium. This milestone marked its entry into interstellar space, where it began studying the plasma density, magnetic fields, and cosmic rays of this new environment. One of its key discoveries in interstellar space was the measurement of plasma density, which revealed that the interstellar medium is denser than the outer regions of the heliosphere. This finding has helped scientists better understand the interaction between the Sun's influence and the broader galaxy. Voyager 1 has provided invaluable data on cosmic rays, high-energy particles originating from outside our solar system. It detected an increase in cosmic ray intensity upon crossing the heliopause, confirming its entry into interstellar space. Additionally, Voyager 1's magnetometer has been instrumental in studying the magnetic field in interstellar space, offering insights into how these fields influence cosmic ray movement and the structure of the interstellar medium. While not a scientific discovery, Voyager 1's golden record deserves mention for its cultural significance. This time capsule contains sounds, images, and messages representing the diversity of life and culture on Earth. As Voyager 1 continues its journey through the galaxy, the golden record serves as a symbolic gesture of humanity's desire to connect with the universe. Even after more than 45 years in space, Voyager 1 continues to make valuable contributions to science. Its instruments, though aging, still function well enough to transmit data about the interstellar environment. These ongoing measurements provide a unique perspective on a region of space that remains largely unexplored. Voyager 1's discoveries have had profound implications for planetary science, astrophysics, and our understanding of the universe. Its journey has inspired generations of scientists, engineers, and dreamers, proving that human curiosity knows no bounds. The discoveries made by Voyager 1 represent some of the most significant achievements in the history of space exploration. From revealing the volcanic activity on Io to venturing into interstellar space, the spacecraft has expanded our knowledge of the solar system and beyond. As Voyager 1 continues its silent journey through the cosmos, It stands as a testament to humanity's enduring quest to explore the unknown and uncover the mysteries of the universe. How long more? Voyager 1, launched in 1977, is humanity's most distant spacecraft and a remarkable testament to engineering and exploration. After more than 4 decades in space, the spacecraft continues to send data back to Earth, but its mission is inevitably approaching its conclusion. Understanding how long Voyager 1 will last requires considering factors like its power supply, instrument functionality, and the challenges of operating in deep space. Voyager 1 is powered by 3 radioisotope thermoelectric generators, RTGs, which convert heat from the decay of plutonium-238 into electricity. When it was launched, these RTGs generated about 470 watts of power. However, the energy output decreases by about 4 watts per year as the plutonium decays. As of 2025, Voyager 1 has about 250 watts of power remaining, and mission engineers have been systematically shutting down non-essential systems to conserve energy for critical instruments. NASA estimates that Voyager 1 will lose the ability to power its scientific instruments by the early 2030, likely marking the end of its ability to collect and transmit meaningful data. Voyager 1 carries several scientific instruments designed to study the interstellar environment, including its plasma wave subsystem, magnetometer, and cosmic ray detector. Despite their age, many of these instruments are still functioning and providing valuable data. However, as the power supply dwindles, these instruments will be gradually turned off to prioritize essential systems like communication. Even if power were not an issue, the wear and tear from decades of operation in the harsh environment of space would eventually render the instruments less reliable.
It's not surprising for something that's 4.5 decades old and has been operating for nearly 3.5 decades.
Voyager 1 communicates with Earth using the Deep Space Network, a system of large radio antennas. Given its immense distance, currently over 15 billion miles, 24 billion kilometers, from Earth, signals take more than 22 hours to travel each way. Maintaining communication requires precise alignment and robust technology. But as the spacecraft continues to drift farther, the signal strength will weaken and communication will eventually become impossible. Even after Voyager 1's instruments and communication systems cease to function, the spacecraft will continue its journey through interstellar space. Traveling at about 38,000 miles per hour, 61,000 kilometers per hour, Voyager 1 will remain a silent ambassador of Earth, carrying its golden record. A time capsule of sounds, music, and images representing humanity intended for any intelligent life it might encounter. Over the next tens of thousands of years, Voyager 1 will pass relatively close to other stars, such as Gliese 445, approximately 40,000 years from now. While it will no longer be operational, its journey will continue, symbolizing human curiosity and exploration. Voyager 1 is nearing the end of its operational life, with its power supply expected to run out in the early 2030. Despite this inevitable conclusion, its contributions to science and its symbolic value will endure far beyond its active years. As it ventures deeper into interstellar space, Voyager 1 will remain a beacon of humanity's desire to explore the unknown and reach for the stars. The need for space exploration. The question of whether Voyager 1 and other spacecraft are worth the investment is a complex one, touching on scientific discovery, technological innovation, cultural significance, and financial cost. Space exploration programs like NASA's Voyager missions have significantly advanced our understanding of the universe, but they also come with substantial costs and logistical challenges. This section explores the value of these missions, weighing their benefits against their costs. One of the strongest arguments in favor of spacecraft like Voyager 1 is the unparalleled scientific knowledge they provide. Voyager 1, for instance, has revolutionized our understanding of the solar system and beyond. It captured detailed images of Jupiter and Saturn, revealing active volcanoes on Io and the thick atmosphere of Titan. Its journey into interstellar space has offered groundbreaking data on plasma density, cosmic rays, and magnetic fields in the interstellar medium. Beyond Voyager, Missions like the Mars rovers and the James Webb Space Telescope have answered fundamental questions about planetary geology, atmospheric conditions, and the origins of the universe. These discoveries deepen humanity's understanding of our place in the cosmos and pave the way for future exploration and innovation. Spacecraft development drives technological advancements that benefit other industries. The challenges of space exploration often lead to breakthroughs in engineering, materials, science, and communication technology. For example, innovations in robotics, imaging systems, and artificial intelligence have applications in fields such as healthcare, transportation, and telecommunications. Space programs also stimulate economic growth by creating high-tech jobs and fostering collaborations between governments, private companies, and academic institutions. The commercial space sector, including companies like SpaceX and Blue Origin, has grown significantly, partly due to the foundational knowledge gained from earlier missions like Voyager. Spacecraft like Voyager 1 have immense cultural and inspirational value. The golden record aboard Voyager 1 is a poignant symbol of humanity's curiosity and desire to connect with the universe. Images like the pale blue dot captured by Voyager 1 as it looked back at Earth remind us of the fragility and unity of life on our planet. These missions inspire people around the world, encouraging the pursuit of science, technology, engineering, and mathematics, STEM, careers. They foster a sense of global collaboration and wonder, showing what humanity can achieve when united by a common goal. Critics argue that the high costs of space exploration could be better spent addressing urgent problems on Earth, such as poverty, healthcare, and climate change. Space missions require billions of dollars, and their benefits, while significant, may not be immediately tangible to the average person. However, proponents counter that the funds allocated to space exploration are relatively small compared to other expenditures, such as defense budgets. Additionally, the long-term benefits of scientific discovery and technological innovation often outweigh the initial investment. What do we expect in the next? As humanity faces global challenges like climate change and resource scarcity, space exploration offers potential solutions. Studying other planets could provide insights into Earth's climate systems, while asteroid mining could address resource shortages. Missions like Voyager 1 demonstrate humanity's ability to reach beyond current limitations, laying the groundwork for future exploration of the Moon, Mars, and beyond. The development of reusable rockets and advancements in space technology are also making space exploration more cost-effective, further justifying the investment. Voyager 1 and other spacecraft are undoubtedly worth the investment given their contributions to scientific discovery, technological innovation, and cultural inspiration. While space exploration comes with high costs, its long-term benefits far outweigh these challenges. By pushing the boundaries of what is possible, missions like Voyager 1 remind us of humanity's potential to explore, innovate, and dream on a cosmic scale. Life through Voyager 1. While its primary mission was to explore the outer planets, Voyager 1 has taken on a profound philosophical role as it ventures into interstellar space, carrying with it humanity's curiosity and the hope of finding answers to the most fundamental question: what is the meaning of life in the universe? Voyager 1's scientific discoveries have provided humanity with an expanded understanding of the cosmos. From its close-up images of Jupiter and Saturn to its measurements of interstellar plasma, the spacecraft has offered insights into the conditions that shape planetary systems and the vast, unexplored interstellar medium. These discoveries provoke deeper questions. Is life unique to Earth, or is it a universal phenomenon? By studying the environments of moons like Europa, which may harbor subsurface oceans, Voyager 1 laid the groundwork for the search for extraterrestrial life. Such missions challenge the anthropocentric view of the universe, suggesting that life could arise in conditions vastly different from those on Earth. This possibility has profound implications for how humanity perceives its role in the cosmic order. Voyager 1's golden record embodies humanity's hope of making a connection with intelligent life elsewhere in the universe. The record contains sounds, images, and greetings from Earth, showcasing the diversity of life and culture on our planet. Its inclusion in the Voyager mission reflects a profound belief that the search for meaning extends beyond scientific discovery to a desire for communication and understanding. The future, unraveling the mysteries of the universe. Looking ahead, it's not just Voyager 1 that could benefit from this combination of space exploration and cutting-edge technology. The possibilities for future missions are exciting. As more spacecraft venture into deeper parts of space, like the ongoing New Horizons mission or the upcoming James Webb Space Telescope, the amount of data will only increase. Each mission will bring back petabytes of information, all of which will need to be analyzed in order to make new discoveries. This is where quantum AI could really shine. It could work in real time, processing data as it comes in, and providing scientists with immediate insights that are accurate and meaningful. We could finally start answering the biggest questions about our solar system, such as the origins of its planets, the nature of dark matter, or even the presence of alien life in faraway star systems. Quantum AI could also help us refine existing theories about space physics. For example, what happens to particles when they travel through the interstellar medium? What are the true boundaries of our solar system? Is there a hidden dark matter halo that surrounds our galaxy? These are just a few of the many mysteries that quantum AI might help us solve, faster and more precisely than ever before. Voyager 1's journey, which has already lasted longer than anyone expected, could become the foundation of even greater discoveries with the added power of this technology. In the grand scheme of things, we're still just scratching the surface of what Voyager 1 has to offer. Yet, as the spacecraft continues to send back data, we're entering a new era of exploration where quantum AI could unlock the universe's deepest secrets in ways we can't even imagine. With this technology, we're not just speeding up data analysis, we're rethinking how we approach the vast, complex puzzles that space presents us. Every new discovery, every new piece of data brings us closer to understanding the universe and possibly our place in it. Voyager 1's mission was always about pushing boundaries and reaching farther than ever before. With quantum AI, we're now equipped to see and understand things that were once out of our reach. That's it for now. Thanks for watching.